This is lesson 11.2, and we're going to continue talking about counting things because that's going to be an issue when we do some probability questions in the next few lessons. So, just to go back to the previous lesson, we used what was called the fundamental counting principle. The fundamental counting principle says that if there are, for instance, 5 shirts and 4 pair of pants, then there will be 5 times 4 or 20 different outfits that you could come out. It says multiply the number of ways that can occur times the number of ways that could occur. We did some examples where we had perhaps singers on the stage. Maybe there were 4 singers who were going to perform. And they said, how many different ways could you have the lineup? Well, I typically do this format. There are 4 ways to fill the first spot. There are 3 ways to fill the second spot because one of them is already set. Then there are 2 ways and 1 way. The fundamental counting principle says multiply the 4 times the 3 times the 2 times the 1, and you would get that there are 24 possible lineups if you have 4, I think I call them singers. Because when you're doing this kind of work, it is very often that you do what I nicknamed step-down multiplication, 4 times 3 times 2 times 1. In mathematics, there is a symbol for it. It is called factorial, and the symbol for it is an exclamation point. So this is for factorial. We didn't talk about it this way in the last lesson. Your calculator, I'm going to clear off my screen, has that exclamation point. If I put in 4 and I do math and I go right till it's on probability and I choose number 4, which was the exclamation point, hit enter, I get the 24. So 4 factorial is 24. 4 times 3 times 2 times 1 is 24. So this first box talks about factorial notation. When we're using the fundamental counting principle, sometimes we don't take everything that is available. For instance, suppose you have 20 figurines, but your shelf will only accommodate 10 of them. So you would say, well, I have 20. I want to pick 10 of them. The way that I arrange them makes it a different kind of look, whether it's tall to short, you like to have the tall one in the middle, maybe the order matters to you. Then you will use what's called a permutation. A permutation is, let's go back up here. It is an ordered arrangement of items that occurs when no item is used more than once and the order of the arrangement makes a difference. So, with the little story I just said, if you have 20 figurines, but you're going to pick 10, then that would be 20, the permutation, taking 10. That's usually read the permutation of 20 items taken 10 at a time. So you're not using them all, which really affects the number of choices you have. There is a formula for this, and the formula says you take the total number, which is the bigger number, and whoops, I'm not sure what that was. Okay, so we take the bigger number and do 20 factorial over, open parentheses, 20 again, minus the smaller number, the number you were picking, 10, and do that factorial. You can do that with your calculator. You could say that is 20, then you'd go math, go to the right, to probability, to factorial, Yes. And then divide it by, open parentheses, 20 minus 10, close parentheses, math, over to probability, choose number 4, which is the factorial symbol, enter. That's huge. That is so huge that the calculator, I made that up on the spur of the minute. It is 6.7044 blah 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 times 10 to the 11th power. That's huge. That's huge. It's too huge to write down. And you won't be confronted with a number like that in any of your assignments. But you get huge number. We have a shortcut. So I haven't even gotten to our example problems yet, but that was a permutation. You can do it with the shortcut, literally typing in 20p10. We're going to get the same huge number, so let me show you. I'm using a newer model. It's slightly different if you use an older model, but I'm going to go to math. I'm going to go to probability again, and look at choice number 2. It is NPR. That's the permutation choice. So I'm going to do number 2. I'm going to type in the 20. I'm going to use my right arrow key to jump to the other box, put in a 10, and I should get the same ginormous number. I got exactly the same thing. I can't even write that number down, but you can use the formula for permutations. 20 items, you only want to take 10 of them. How many different arrangements are there? Or you can use the shortcut notation. If you have an older model of calculator, then before you go get the P, you have to type in the 20 first. Then you go get it, and it will literally say NPR. And then when you, after that, you will type a 10. It's not as pretty in the older models. All right, so either way we did it, we got huge number. All right, now let's just practice with the both factorials and in a minute with permutation on our calculator. It does say exactly what to do with the older models and with the newer models. These are also available in those class notes that you could print out from the probability lesson. In the face-to-face class, it's the yellow packet. All right, this one, 26 factorial divided by 23 factorial. So I have 26 factorial, math. Takes a few key presses to get to it. Factorial is number 4 divided by 22 factorial, so there's math, number 4. So there's 26 factorial divided by 22 factorial, and I get the answer of 358,800. 358,800. Very large number. If we did one where the numerator value was so large that the calculator was shutting down on us, there is something else you can do. If you have this expression, take the smaller factorial and write it down. The larger one, 26 factorial, means 26 times 25 times 24 times 23. Now when you get to that same number, just say factorial, which means and so on, all the rest of them. Divide out that common factor, multiply these, and you're going to get the same answer. You may not have to do that in your homework, but if you get an overflow error, meaning that the numbers are too large, then this is what you'll want to do. All right, the next one, 26 factorial divided by 22. Whoops. I think that's what I did for this one. I'm so sorry. This is 358, 800, and let's see what I get up here. It's 26, math, I did the wrong problem, factorial, divided by 23. I had the wrong number in the previous problem, but it was number 2. 15,600. So if you're keeping up with this, this one was literally 15,600. I would have noticed that if I had checked it with this. And let's see, 26 times 25 times 24. 26 times 25 times 24. Yes, there's the 15,600. So I'm sorry about that mistake. I grabbed the 22 and I did that one instead. All right, let's move on. Let's suppose we are doing this one. Now, if I needed to, I could say that is 11 factorial, and the top is 18 times 17 times 16 times 15 times 14, wow, times 13 times 12 times 11. Stop factorial. I wouldn't do this, but I want you to know that we can divide those out, and if you multiply this, you better get the same thing I'd get if I did it with the factorial notation. So this is not an option you'll probably have to do. So it is 18 factorial divided by 11 factorial, and you get a really large number. I'm not going to copy it, but it is 160,392,960. So it's huge, and that's the same thing you would get if you multiplied all of those. So when would you ever, I just want to take a minute because I hope I haven't confused you. If you put this in your home screen calculator and it works out fine, then great. But let me give you an example of something that wouldn't. If you had 102 factorial over 101 factorial, those are almost the same number. But if you tried to do that with your calculator, you did 102 factorial divided by 101 factorial, and you hit enter, it would give you an error overflow. What happens is when it tries to do the 102 factorial, the number is larger than this calculator can handle. Whereas if I did it with the shortcut way, which is 101 factorial, the top is 102 times 101. I can stop and say factorial. Those divide out. My answer is 102. It was not at all a hard or a big answer, but the calculator was going to figure this out and try to figure this out and then divide them, and the numbers were too big. The shortcut helped. So if you ever get that error overflow, then you need to use the shortcut. All right, now we can pick up the pace. We're going to look for this permutation. You can either use the permutation formula, which is n factorial over, open parentheses, n minus r factorial, or you can literally put in 7 permutation 3 at a time. I choose to do this. So calculator, clear that out. I'm going to go math. Once again, go to probability. Number 2 is permutation, and of course I have forgotten it's 7 and 3, so it is 7. Use your jump arrow, 3, enter, 210. So if you had 7 items, you were going to select 3 of them, maybe for display. The order mattered. It would turn out that you have 210 choices. Let's look at number 5. The word problems make you think about why order matters, I hope. It says a club with 5 members is to choose 3 officers. First person chosen is president, second is vice president, third is secretary-treasurer. Each is to be held by 1 person. No person can hold more than 1. In how many ways can those offices be filled? Now, if the first one's president and the second's vice president, then it matters the order that they're chosen. So you have 5. Because order matters, we're doing a permutation taken 3 at a time. Go to my calculator. I've got math. Choose number 2. I have 5. Hit the right arrow. Taken 3 at a time. Enter. There are 60 ways that you could have a slate of officers. Next, for a segment of a radio show, a disc jockey can play 5 records. If there are 7 records to select from, in how many ways can the program be arranged? Because if you have a different order for the songs, then it's a different program. So there are 7 to choose from. Because order matters, we're doing a permutation. We're taking them 5 at a time. So 7 taken 5 at a time. So I'll go math. Number 2, permutation. 7 taken 5 at a time. 25, 20. All right, in the next one, it says in a race in which 5 automobiles are entered and there are no ties, in how many ways can the first 3 finishers come in? Well, order definitely matters. First, second, third, yes, they are different. So we'll use a permutation, and we have 5. We're going to take them 3 at a time. Well, we just did that up here. So I know that my answer is 60. There's 60 different ways that we could have 3 finishers. Number 8. There are 8 performers who will present their comedy acts this weekend at a comedy club. In how many different ways are there to schedule their appearances? Now this should look familiar because it looks like a problem that we use the fundamental counting principle on. And you could. But order matters, so I could use a permutation. There are 8 performers. I'm choosing all 8 of them. So I will do the permutation of 8 taken 8 at a time. Let's see what we get. Math. Sorry, I've got some background noise. Stopped that. We're going to choose number 2, and we are doing 8 taken 8 at a time. 8, right arrow, 8, and we get 40,320. So there are 40,320 different ways we could do this. We could have, if we wanted to, said there are 8 ways to fill the first spot, 7 to fill the second, then 6, then 5, then 4, then 3, then 2, then 1. Use a fundamental counting principle, multiply those out, and we get the same thing. Number 9. In an encyclopedia of language, the author presents 5 sentences that make a reasonable paragraph regardless of their order. It is a different paragraph, but it's supposed to make some sense. So, in how many different orders can the 5 sentences be arranged? We have 5. We are looking at the permutations of taking all 5 of them. So it is permutation 5 taken 5 at a time. So go to math, go to probability, choose number 2. We're 5 and 5. 5 for N, 5 for R. We get 120. There are 120 different paragraphs you could write with those 5 sentences. Number 10. There are 9 performers who will present their comedy acts this weekend at a comedy club. One of the performers insists on being the last one. Now, when he insists, his spot is taken and there are now only 8 performers to worry about. So you've got 8. Order matters. You're taking all 8 of those, so we're going to do the permutations of 8 taken 8 at a time. And if I did this on my calculator, I would get 40,320. Let me show you how we did this when we were studying the fundamental counting principle. Let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 spots. There is one guy who demands to be last. He wants to close the story. That means I have 8 to work on. There are 8 to choose from for the first position. 7, 6, 5, 4, 3, 2, and 1 there, and it multiplies by that 1, so it didn't change it. The product of those is 40,320. Last question. At a benefit concert, 12 bands have volunteered to perform, but there's only enough time for 9 of them. How many lineups are possible? Order matters, so it's a permutation. There are 12, but we're only taking 9. And then we want to see how many ways we could arrange those. So last time I will do math, go to probability, choose number 2. We have got 12, but we're only taking 9. Wow. There are 79,833,600. And I'm not even going to write that number down, but it is a very large number that you would write in here. I guess I could. It's 79,833,600. Now these were all permutations because order mattered. You will find in our next lesson what happens if the order doesn't matter. Instead of picking a president, a vice president, and a secretary, what if you're just getting a committee of 3? And it doesn't matter if you're picked first, second, or third. It just matters that you're picked. That will not be permutations. That will be something called combinations. And we'll look at that in the next lesson. Enjoy.